Okay, so hey guys, so we're going to go over day 1 notes today. Okay, so so day 1, mole math. Okay, so we use a unit called the mole, or MOL. Okay, so that's going to be, it's just a standard measurement. So just like how we use G to represent grams, or M to use for meters. Okay, this is the same thing. Moles is going to be a standard measurement of that. Okay, so it's used to measure the amount of a substance. So the mole can represent mass. Okay, so again, represented in grams. Okay, or it can be volume, which is represented in liters. Or it can represent an amount. Okay, or particles. Okay, so all these things, mass, volume, and amount, can represent a mole. Okay, and then you must always go through a mole. So 1 mole can equal our molar mass. Okay, 1 mole can also equal 22.4 liters. Okay, because remember, a mole can also represent a volume. So 1 mole can also equal 6.02 times 10 to the 23rd particles. Okay, so moving forward, Avogadro's number is considered 6.02 times 10 to the 23rd particles. And is also called a mole. Okay, so again, Avogadro's number is considered 6.02 times 10 to the 23rd particles and is also called a mole. Okay, so 1 dozen of anything can be equivalent to 12 items, right? So a dozen cookies is 12 cookies. So if we have 3 dozen cookies, so what's 3 times 12? That's going to equal 36 cookies. Okay, and then half a dozen donuts is equivalent to, well, 12 divided by 0.5. Half of 12 is 6 donuts. Okay, so a dozen is a counting unit equal to 12 of any object. So a mole is a counting unit equal to 6.02 times 10 to the 23rd of any object. Okay, even really small ones like atoms, molecules, or formula units. Okay, so what's so special about 6.02 times 10 to the 23rd, and why do scientists use that number? Well, for one, it's a conversion factor. Okay, and then 2, it also allows us to manipulate small particles as if they were one whole part. Okay, so it allows us to manipulate many small particles as if they were one whole part. Okay, so examples of conversion factors Well, remember, if 1 mole equals 6.02 times 10 to the 23rd particles, which remember particles are atoms, molecules, or formula units, well, 1 mole of copper is therefore equivalent to 6.02 times 10 to the 23rd atoms of copper. Okay, if we have 1 mole of CuCl2, then that means that we're going to have 6.02 times 10 to the 23rd formula units. Okay, 1 mole of CO2 is also going to be 6.02 times 10 to the 23rd molecules of CO2. Okay, and then the amount of substance containing Avogadro's number. Okay, sorry about that. Okay, so again, this the amount of substance containing Avogadro's number of any kind of chemical unit is called a mole of that substance. So 1 mole of K, or potassium, contains 6.02 times 10 to the 23rd atoms. Okay, and then 1 mole of NaOH contains 6.02 times 10 to the 23rd formula units. Okay, so moving on to molar mass. So molar mass is the mass of 1 mole of any substance. Okay, so molar mass is the mass of 1 mole of any substance. Okay, other names for molar mass include formula mass, okay, gram formula mass, and molecular weight. Okay, but for the most part, the ones that we're going to use is mainly molar mass. Okay, these other ones we're not really going to use. Okay, but it's just for your information. Okay, so 1 mole of any element, okay, we'll have a mass in grams corresponding to the value of its atomic mass. Okay, so remember, you can find your atomic mass on the periodic table. Okay, so for example, 1 mole of carbon is going to equal what? So let's go ahead and take a look at our periodic table. Okay, so carbon is right here. So carbon's atomic mass is 12.011. Okay, so 1 mole of carbon is going to be equivalent to 12.011 grams per mole. Okay, 1 mole of nitrogen is going to be equivalent to 28.014. Okay, now before you get confused, well, be careful, because nitrogen is actually considered a diatomic element. Okay, what diatomic means, we'll get to that in a second. Okay, but for nitrogen is supposed to be 14.007, but because it's a diatomic, okay, I'm just going to move this. Okay, because it's a diatomic, that means we're going to have to multiply it by 2. Okay, and that'll equal the 28.014. Okay, it's the atomic mass from the periodic table. Okay, so back to diatomic elements. Okay, so diatomic elements, if my computer decides to, okay, agree with me. So diatomic elements. Our diatomic elements are going to be hydrogen, okay, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so what basically that means is that there's always going to be two of them. So nitrogen 2, oxygen 2, fluorine 2, chlorine 2, bromine 2, and iodine 2. Okay, so they are always in pairs. They are never found all by themselves. Okay, so an easy way to remember that, I'm not really sure if you guys can see it, but remember H7. Okay, so if you have hydrogen right here, so that's going to represent your H, and then 7 is going to start at atomic number 7, which is nitrogen, and it kind of creates the number 7 if you look at it. Okay, so these 6 elements right here, so H7, and it starts at atomic number 7, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, which is also in group 7A. Okay, so hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. That's going to be your H7. You have to memorize these. You have to know these. Okay, they will not be given to you, so you have to remember and memorize what our diatomics are. Okay, so moving forward, so 1 mole 1 mole of any molecule or compound will have a mass in grams corresponding to the value of its molar mass. So it's the sum of the masses of the element that composes it. So if I have H2O, well, your question is, how much does this weigh? What is the mass of H2O? Well, first off, hydrogen and oxygen are the only 2 elements that we have for H2O. Okay, hydrogen has the atomic mass of 1.008, and then we're going to multiply it by 2 because that's how many hydrogens we have. Okay, when we multiply that, we get 2.016. Now for oxygen, oxygen's atomic mass is 15.999, and then we're going to multiply that by 1 because we only have 1 oxygen. Okay, so when we add those up, 15.999 plus 2.016, well, our total molar mass is going to be 18.015 grams per mole. Okay, now another example, we have CaNO3 2. Okay, well, if you have, these are all your elements we have. We have calcium, nitrogen, and oxygen. You always want to identify, well, what elements do we have in our molecule? So calcium's atomic mass is this, nitrogen's atomic mass, and oxygen's atomic mass. Then we're going to multiply that again by, well, how many calciums do we have? We only have 1 calcium. We have 2 nitrogens, okay? So if you have a subscript outside of your parentheses, then that means you're going to have to distribute that 2 into the parentheses. So that means we have 2 nitrogens and 6 oxygens. Okay, so you're going to have to multiply. Okay, so when you multiply those all up and then add them together, your total molar mass is 164.068 grams per mole. Okay, so that means this molecule right here weighs this much or has this much mass. Okay? All right, so let's go ahead and work a few practice problems together. Okay, so first off, we have potassium carbonate. Okay, so first off, what is potassium carbonate? Do you guys remember that? So potassium is K. Okay, so potassium is K. I don't think I want to be in that close. Okay. Okay, and it has a charge of +1. Carbonate is CO3, which has a charge of -2. Okay, if you don't know where I got that, let me grab a periodic table. So potassium is right here on our periodic table. And what's its charge? Well, look up here. We have a +1 charge. Okay, and then carbonate, that's going to be a polyatomic, so that's going to be on the back of our periodic table. So carbonate is CO3 with a charge of -2. Okay, so remember what we do with our charges. Our charges are going to become the subscripts for the opposite element. So we end up with K2CO3. Okay, so again, okay, our first step is the number of potassium ions do we have. So how many do we have? We have 2 potassium ions, or atoms rather. Okay, how many carbon atoms do we have? We have 1. And how many oxygens do we have? We have 3. Okay, so now that you have identified how many of each atom you have, now let's go ahead and go back and figure out, okay, what's the atomic mass of each. Okay, so I'll go ahead and put the split screen back up so you guys can kind of take a look at the periodic table. Okay, so let's see. Okay, so potassium is right here again, so that's 39.098. Okay, so 39.098 is our atomic mass. Okay, and then carbon is going to be 12.011, and oxygen's atomic mass is 15.99. Okay, now you're going to go ahead and multiply those all together. So 39.098 times 2 is going to be 78.196. 12.011 times 1 is still going to be 12.011. Then 15.999 times 3 is 47.997. Okay, so what's your final answer? Well, when you add those all up, your final answer is 138.204 grams per mole of K2CO3. Okay, all right. So let's go ahead and move on to ammonium sulfate. So again, what's ammonium? That's going to be on the back of our periodic table. Do I have the back of the periodic table on here? I do. Okay, so let's see. Ammonium is going to be right here. So that's NH4 with a +1 charge. So NH4 with a +1 charge. And then sulfate is going to be right here at the bottom. Okay, so that's SO4 with a -2 charge. Okay, so, oops, that's supposed to be negative. Okay, so remember that they are going to crisscross, so we end up with NH4, 2 SO4. Okay, so now we have to go ahead and let me go ahead and just get rid of this. Okay, so now we have to go ahead and do what we did earlier. How many of each element do we have? So remember, nitrogen, since we have a subscript in parentheses, we're going to have to distribute that. So 2 goes to 2 goes to nitrogen, and it also goes to hydrogen. Okay, so how many nitrogen atoms do we have? We have 2. Okay, how many hydrogen atoms do we have? Well, 4 times 2 is 8. How many sulfur atoms do we have? 1. And how many oxygens do we have? We have 4. Okay, so again, look at your periodic table and try to figure out what the atomic mass is for each of these atoms. So nitrogen is 14.007, hydrogen is 1.008, sulfur is 32.066, and oxygen is 15.999. Okay, so you're going to go ahead and multiply these two values together, and you should end up with 28.014, 8.064, 32.066, and 63.996. Okay, so when you add those values up all together, you should end up with 132.140 grams per mole of, sorry, not K2, that was the last problem. So NH4, 2, SO4. Okay? All right, so that concludes Day 1 notes. If you have any questions, please just let us know.